Okay, so in this next lesson, we're going to learn about a quadratic function in vertex form. So far we've done a quadratic function in standard form and factored form, and now we're going to do vertex form. The reason we have a quadratic function in vertex form is it actually helps us find the vertex of our graph. So the a value, again, just like the other two examples, when a is greater than 0, it means our parabola opens up. When a is less than 0, it means our parabola opens down. But this helps me find the vertex. So the vertex is always following that negative. So to kind of help you remember what you're going to do is your vertex is like the opposite sign of whatever that connecting sign is, because it's following the negative. So my vertex, even though it says negative x minus h, which actually would be positive h. And then your y value is that constant, and it's the same sign, so it would just be k. So now that we talked about that, let's actually figure this out. So right away, we know our vertex is the opposite sign of that connecting sign. So the opposite of x minus 3 would be positive 3. And then our y value is exactly the way it looks, so it would be negative 4. All right. And then our a value, because it's positive, that means the graph opens up. Perfect. So let's go ahead and try to draw this. So we have a vertex of x is 3 and y is negative 4. So it'd be right here. All right. And then if we kind of graph this, if we want to see what the rest of the graph looks like, let's go ahead and do that. So we're going to go to our graphing calculator. And we're going to type this equation in. So 2 bracket x minus 3, squared minus 4 graph. There you go. And then you could find x-intercepts from here or y-intercepts or whatever you want to do to help you with that graph. If you're like, I forgot how to do that, your x-intercept, you go second, trace. Let's use the 0 option. We're going to move our cursor so it's close to that x-intercept. There it is. We'll go left, right. There's my first x-intercept. It's about 1.58. And then I can find the other x-intercept as well. Second, trace, choose option 2, 0. Move my cursor over, left bound, right bound, enter, and I get 4.4. Let's go ahead and draw that. And that's what my graph will look like. There we go. Perfect. All right. So now we're going to just practice that a bit more. So it asks you for each of these equations, determine the direction of the opening and the coordinates of the vertex. So right away, there's no a value. We assume the a value would be 1, so that means it's a positive 1. The graph is going to open up. Our vertex always opposite to the connecting sign, so it's going to be positive 2. And the y value is that constant, which is the same sign, which is just 5. And then your axis of symmetry is always the x value of your vertex. So in this case, it's x equals 2. And you need to make sure you're writing that in the right format. So it should be written as an equation, x equals 2. Don't just write 2 or else the notation would be wrong. And then you could graph this as well. I'm just going to kind of keep motoring through these questions here. So the next one, the direction of the opening, because I have a negative a value, it's going to be opening down. My vertex, again, we're always going opposite sign of that x value, so it's going to be negative 1. And then the y value is the same sign, negative 4. And if you're wondering why that is, if we were to write in that format above where it had x minus h squared plus k, in this case, you would end up with x minus negative 1, right? In order to have that format match. And then your x value would be negative 1. But for most kids, it's just easier to think opposite sign for the x value, same sign for the y value. All right, so then our axis of symmetry is always the x value of the vertex, right? And you write it as an equation, so we write it as x equals -1. Last one, we have a -1/5 as our a value, so that means our graph opens down. And then my vertex, again, I'm always going opposite sign, so it's going to be -5. And the y value is same sign, +10. So the axis of symmetry is that x value of the vertex, which in this case is -5. Perfect. All right, let's try example 3. Notice how it says determine the value of a. They give us an ordered pair. So whenever you're given an ordered pair, you can substitute it into an equation to find a missing value. In this case, that missing value is a. So I want to find the value of a. So I'm going to replace y with 85.3. And I'm going to replace x with 10. Now let's go ahead and try to solve for a. So I have 85.3. 10 minus 12 squared gives me +4. Now to solve, I'm going to subtract that 47.5 over to the other side. And that gives me 37.8. And then I'll divide the 4 to get a by itself. And that gives me 9.45. So then my final equation, a is 9.45 bracket x minus 12 squared plus 47.5. There we go. All right, example 4. Alex kicks a soccer ball from the ground. After 2 seconds, the ball reaches its maximum point. So here goes the soccer ball. It starts on the ground at 2 seconds. So that would be like your axis of symmetry. It reaches its maximum point of 20. So right away, we know our vertex when x is 2, y is 20. And then lands at the ground after 4 seconds. That would be my other x-intercept. Determine the quadratic function in vertex form. All right, so we know our vertex. So we're going to have x minus 2 squared plus 20. There we go. Opposite sign is the x value. And then you can use any ordered pair. I'm going to use the 4 to help me find the a value. So when y is 0, x is 4. That's what I'm replacing there. So 4 minus 2 squared gives me, 4 minus 2 is 2, squared gives me 4, so I have 4a plus 20. I can subtract that 20 over to the 0 and I get -20 equals 4a. Divide both sides by 4 and I get an a value of -5. So now that I know my a value, I can write my equation, which is y equals -5 bracket x minus 2 squared plus 20. And then for b, it says, what was the height at 1 second? So we can just replace x with 1. And then we'll type that in our calculator. And you should get a y value of 15 when you type it in. Great. Okay, moving on to example 5. So it says determine the quadratic equation. So you're given the vertex, you're asked to find the equation. So we have our a value, vertex, opposite sign for the x. So I'm going to have x minus 2 squared. Same sign for the y, so I have +6. Substitute a point. You can use any point. My y-intercept is definitely the easiest one to use. So when x is 0, y is 2. So I'm going to replace y with 2, replace x with 0. 0 minus 2 is -2 squared gives me 4a. subtract that 6 over. 2 minus 6 is -4 equals 4a, so that means a would have to equal -1. So my equation, let's go ahead and write it in blue, would be y equals -1 x minus 2 squared plus 6. And then you could graph this on your calculator and just make sure the pictures match if you want to know if you did it correctly. Okay, let's try the other one. So y equals a. This time my vertex is -3, -4, opposite sign for x, so I have x plus 3 squared, same sign for y, minus 4. Now I'm going to just use the y-intercept again. So when x is 0, y is 5. So I'm replacing y with 5 and replacing x with 0. Zero plus 3 squared. 0 plus 3 is 3. 3 squared is 9, so I have 9a. Add the 4 over. 5 plus 4 is 9, so I end up with 9 equals 9a, so then a would have to be 1. Now I'm going to use my blue again, write that final equation out, so I have y equals 1, bracket x plus 3 squared minus 4. Beauty. Okay, there's my two equations. Now we just have a couple of multiple choice questions. Here it says a parabola has a vertex at -6, 4 and opens down. A possible equation would be, so if it opens down, that means we would need a negative value. So right away we know a is wrong because that's a positive a value. If my vertex is -6, I would need x plus 6, right? Because it's always opposite connecting sign, and then plus 4 on the outside. So my x value would be x plus 6 inside, plus 4. So that means the correct answer would have to be D. You could also graph it and double check it on your calculator as well. Now we have a range question. So the range you can find also using the vertex. So I know my vertex, the x value is opposite, so it'd be 3. And the y value is -5. Let's draw this out. So when x is 3, y is -5, it's going to go down because a negative there, so it's going to look kind of like that. You could also graph it if you wanted, but we know that y is going to be less than or equal to -5, making my answer B.